In this video, I'm going to find the limit of the difference quotient for the function f of x equals 2x plus 2, where a equals 4. So we will write down the limit of the difference quotient. So that's the limit as h goes to 0 of f of a plus h minus f of a all divided by h. Now, the interesting thing about difference quotient is these generally almost always work out. So let's look at this. So this is the limit as h goes to 0. So we have to calculate f of a plus h. So let's put a big line here. So f of a plus h is going to be, a is 4, so that's going to be 2 times 4 plus h plus 2 minus f of a, so that's f of 4, so that's going to be 2 times 4 plus 2. And it's really important here to remember your parentheses, or else you'll get these signs wrong. And we're dividing all of this by h. And so now we're going to multiply this out. And so we have the limit as h goes to 0. Draw our line. This is 8 plus 2h, multiply distributing the 2, plus 2 minus, and I'll distribute the minus sign, so minus 8 minus 2 all divided by h. And now you can see you've got an 8 here and a minus 8 here, a plus 2 here and a minus 2 here, and so we're left with the limit as h goes to 0 of 2h divided by h. And again, because h is never actually 0 when we're taking a limit, it's close to 0, but it's not exactly 0, we can divide out by h. Limit as h goes to 0 of 2, and the h is canceled, so we just end up with a 2, and we're taking the limit of a constant, so that's 2. Now, one thing to note is that this limit, again, we can see it here most easily, this limit is of an indeterminate form. It actually has a value, but it's of indeterminate form. And again, if you went back to the beginning here and looked at what happens when h goes to 0 of the numerator, that limit is 0, and the limit as h goes to 0 of h is also 0. So this is of indeterminate form, but again, this limit is equal to 2.